Hello there, so here I am to proudly present to you my own self-built and self-designed 8-bit computer with 12-bit memory addressing, so I have 4 kilobytes of RAM. I have a display module, which is an EEPROM with a multiplexer, and it has different modes. I can switch it to hexadecimal and binary modes. So I have a power supply unit, the LM2676. I have a clock module, which is currently just an NE555. I have a bus monitor, a control monitor. I have memory address register 1. I have the memory module with a CI66256, I believe. I have a memory address register 2, so I have a total of 12 bits memory addressing. I have register A, I have the ALU consisting of two 4181 ALU chips. I have register B. I have my program counter, which has the carry bit from the ALU wired in, which allows me to do conditional jumping. I have my instruction counter, which counts the sub-steps of each instruction. I have an instruction register, which has 4 bits instruction and 4 bits payload. I have a control unit, which consists of 3 EEPROMs controlling the 24 control lines based on the instruction counter and the instruction register. I have a BIOS chip, which contains a kind of a bootloader, and I have a program cartridge, which contains the actual program. The bootloader has 26 lines of code in it, so 26 bytes, which fires up the cartridge, and the cartridge has a dip switch with 4 bits, so I can address multiple cartridges if I like during my program execution. So once I start the clock, we will see the counter starting at 27 because that's the first program line to be loaded. Then it will count up to 49, at which point the complete program from this cartridge EEPROM is loaded into the memory, and then the program execution starts, which will actually count the Fibonacci numbers up to 233, at which point the computer should halt. So let's start the execution. So we can see the line number counting up to 49 now. This light indicates that the BIOS chip is active at line 49 when the program is completely loaded, which is indicated by a double halt signal. The BIOS will terminate and the program execution will take over. So we should see any second now the BIOS active LED turning off. Now we have the program running from RAM and the Fibonacci sequence counting up to 233, at which point the halt signal will come up and the computer will stop the execution, which is now. Yay.